Hi, everybody. I'm Kathleen Jasper. Welcome to our Praxis Core 5733, the Praxis Core Math webinar. Now, if you registered for this webinar through our website, then you received the handouts that we're going to be using today during the webinar. If you haven't received them, go ahead and check your email. They should be there. And if you're watching this in the future, which is previous or ahead of the live, then you should be able to access them right on the page where you get this webinar. So you can get these, check your email. If you registered for the webinar, you should have them. Today, we're going to go through about 11 problems from the handout that you received. We're going to cover all three areas of the Praxis Core Math exam. So we're going to cover the numbers and quantity, the data, probability, and stats, and the algebra and geometry section. All three are evenly distributed throughout the test, so it's about 33 to 35% for each content category. So we're going to hit all of them evenly today. Numbers and quantity, data, probability, and statistics, and algebra and geometry. We're going to cover all of those today, all right? So when we talk about number and quantity, it can be a variety of things. It can be anything from, find this number on a number line all the way to do this percentage increase or decrease or whatever. So it can be very, very broad. There's a lot going on here. And number and quantity will be assessed on inside a lot of the other questions. For example, even if I'm in my data, probability, and stats section, and I'm dealing with this situation here, which is a data, probability, and stats question, it will still be a number and quantity question because we're dealing with percentages and things like that. So a lot of these questions overlap and actually can be assessed in several different areas. So we'll mention that as we get through them. But I just wanted you to know that. So number and quantity is the first content category on the exam. There are going to be 20 questions in this particular area that you're going to have to do. So 36% of the test is coming from number and quantity. So when we talk about number and quantity, let's take a look at number 1 in the handout. And you can see that I always like to go to my answer choices first when I'm talking about my questions, because my answer choices will often lead me to kind of think, okay, this is this kind of question or that kind of question. In this case, we can't really see much. We just see a bunch of numbers, so it's not telling me much. Let's get into the question. If the number 345,678.012, so this number right here, is multiplied by 100, which digit will be in the 10,000s place? All right, so what I like to do is write it out. I'm one of those who needs to take it out of the question and kind of write it myself so that I can see it a little bit better. And in this case, here's my number, and it's saying that I'm multiplying this number by 100. Now, this is a place value question. This is basically asking you which number is in this place or what value is this place. So we're saying we're multiplying by 100. Now, here's my decimal. If I multiply by 100, remember this from elementary, middle, and high school, you're going to move that decimal over how many? 2. 1, 2, because there are 2 zeros in 100. So I'm going to move this decimal 1, 2 here, which my number is going to be 345,678,01.2. So now I'm going to add my commas now that I've moved that decimal over. And when I do a comma after each whole number, or every three whole numbers, and I have 34,567,801.2. So that's what happened when I multiplied it by 100. Now it's asking me which digit will be in the 10,000s place. Well, I know that this is the ones place, this is the tens place, this is the hundreds, this is the thousands, and this is the 10,000s place. So 6 is in the 10,000s place. So that's going to be E. Now I know that one's very easy. Trust me. They're not all that easy, but I wanted to get your brain warmed up a little bit and get going. So this is a place value question, and it is relatively easy. Now they get a little bit harder. So now we're getting into percentages. This is number 5 in your handout. Let me go ahead and get my answer key here. I don't like to do math without an answer key. All right. So this is number 5, and I can see right away, because I always go to my answer choices first, right through here, I'm looking at percentages here. Okay. And I can see I have increase, decrease, increase, decrease, increase. So right away, my brain should go, all right, I'm going to be looking for a percentage increase or decrease. So I'm going to have to find a percentage, and I'm going to have to figure out if it got bigger or smaller. All right. So let me go ahead and erase some of this so you don't get confused. But I always like to go to my answer choices first, because it kind of preps me for my task and what I'm supposed to be doing. All right. I also like to go to my question stem first. Is the change a increase or a decrease? All right. And then it says what percent of change in the number of manatees from 2012 to 2019. So I kind of work backwards. It really helps me with math and all questions. I suggest you do the same thing, because if you start up here and you start reading, you get lost in the language. And then by the time you get to the end, you have to reread it again. So I like to start here at the task. We have to figure out the percentage and if it was an increase or a decrease, okay? So let's go ahead and go into the question now. In 2012, the population of manatees in Florida's waterways was approximately 6,550. In 2019, the population was estimated to be 8,750. What is the percent change in the number of manatees from 2012 to 2019? Well, right away, I know that there was an increase, right? Because I was at 6,550 and now I'm at 8,750. So I can eliminate any answer choice that says decrease, because we didn't decrease, we increased. Went from 6,500-ish to 8,700-ish. So decrease is out, decrease is out. Now I'm down to 3 answer choices, A, C, or E. Makes it much easier. Now what I need to do is find the difference in manatees, because I have to figure out the percentage increase. So the way I do that is pretty simple. I just take 8,750 and I subtract 6,550, because I'm taking the new population of manatees and I'm subtracting the old population of manatees to figure out how many manatees we added in those years. How many manatees did we increase? And when I do, I get 2,200, because 0 minus 0 is 0, 5 minus 5 is 0, 7 minus 5 is 2, and 8 minus 6 is 2. So check my math in the chat. If you see a mistake, let me know. I do make lots of mistakes, especially in the middle of a webinar. But I have 2,200 here. So that's awesome. I know that I went up 2,200 manatees. All right. Now, I'm going to take that 2,200 and I'm going to put it over my original population here. That was sloppy. Sorry about that. Ooh. Let me change it to a different color. This is the OG, the original. Okay, right there, 6,550. But my increase was 2,200. So you always put the number you increased over the original, because we're figuring out from the original to this is how much percent increase. The other thing I want you to pay attention to is the top number is always going to be smaller than the bottom number, because we're looking for a percentage. And when we look for a percentage, we know that 25.1% is actually 0.251, right? Because 100% is multiplying it by 100. So really the number is 0.251. This one is 0.336. And this one here is 0.359. So in order to get a number that is less than 1, we need to have a smaller number on top here than the bottom. And when we do, what I'm going to have you do is do this with your calculator. 2,200 divided by 6,550, 6,550, and we get 0.3358. And it says round to the nearest, does it say round? I don't think it says round, but I can see I've got 1 decimal point over. So I need to take this 1, 2, because I'm talking about a percentage, and I get 33 point, not 5, but 6%, because we're going to round up because of that 8. And that makes C our correct answer there. So just to recap, we first eliminated B and D because we didn't have a decrease, we had an increase. We went from 65.50 to 87.50. So I can eliminate all the decreases, okay? That brings me down to 3 answer choices now. When I find the difference and figure out that we increased 2,200, now I know how many more manatees I had in 2019 than I had in 2012. So then I put the new number, the added number, the 2,200, the additional, over the original, and I get 65.50, and I put it over 65.50, and when I divide, I get 2,200 divided by 65.50. And when I do, I get my percent increase is 33.6%. So that's how you do it. You basically determine if it's an increase or a decrease. We said it was an increase. Figure out the difference in numbers. In this case, we're talking about manatees. There were 22 additional manatees in 2019 than there were in 2012. We put the difference over the original, and that gives us 33.6%, okay? So you can see how number and quantity can be as easy as what integer is in the 10,000s place, which is an elementary school skill, really, to a much more complicated, probably 7th to 9th grade skill here on this. So those are both number and quantity. So I want you to pay attention to that when you're on the test. Not like you have to think, oh, this is number and quantity and this is algebra. It just is helpful for you to know what skill set this is coming from. Now, the next piece is the data probability and stats. Oh, and one more thing I wanted to tell you. You know, we were using a calculator here. Now, I was using my handheld calculator because I'm in the middle of a presentation and clicking on the screen is very annoying. However, when you go in to take your Praxis Core, you will not be able to use a handheld calculator. Instead, and let me pull this up here, you are going to have to use, and I will pull this here, you're going to have to use one of these numbers here, all right? One of these, can I make it bigger? No, I can't, I guess. That's okay. One of these calculators here. Now, I recommend you pull this up on your computer and use this calculator when you practice, because you're not going to be able to do the handheld. I'm using the handheld because it makes it easier for me in presentation mode. You don't have that luxury. Now, if you're watching this webinar and you're taking the FTCE GK math, you can get a handheld calculator. You can ask your proctor, but the Praxis Core ETS will not let you do that. So it's a little difference between those two exams. So what we're doing today will help you with FTCE math, and it'll also help you with Praxis Math. Obviously, it's a Praxis Core webinar. However, you won't get the handheld if you're a Praxis Core Math person. You have to use the online one. So pull that up when you're doing your math and practice with the online calculator. All right, that brings me to data probability and statistics, and this is going to be 32% of the test. That's going to be about 18 questions, okay, give or take, depending on if you have any extra questions that they're field testing, okay? So we've got 18 questions, and this is what data probability and stats might look like. Now, we are looking at some data here, but notice the percentages. Notice I have 25%, 28%, 15%, 8%, and I'm missing a percentage here. Now, this can also go under the number and quantity, because we are talking about percentages and we're having to figure out the number and quantity. So this is an example where number and quantity kind of filters on into other test questions, okay? So just want to make that clear for you there. So I already see I'm looking at a pie graph, okay? And on this test, on the Praxis Core Math, you will have to write in answers. And in this case, number 6 on our handout, there's a little box on your handout for you to write the answer. Now, these are harder than simply multiple choice answers, because in multiple choice, when you have an A, B, C, D, and E on the Praxis Math, it goes to E. You can like do process of elimination, and you can use your answer choices to help you. And in this case, you can't do that because there are no answer choices. So you've got to figure this out, check your math, and make sure you're right. Answer choices help. I'm a fan of answer choices. All right, so we're looking at a pie graph. I know right away I'm going to be dealing in percents, and the pie graph is 100%. The whole thing equals 100%, always, never equals anything else, okay? So it says the pie chart shows the results of 300 students' favorite electives in high school. How many students choose photography as their favorite elective? Well, surprise, surprise, they're asking us about the piece of the graph that is missing a bunch of information. Not only am I missing the percentage, but I also have to figure out how many students. Well, there's a couple of tricks you can do here. I want you to be very careful because this is like a 2 or 3 part question. And what happens is sometimes because it's a fill in the blank or you have to write in the blank, you might skip a step. So we want to make sure that we pay close attention to the question stem. How many students choose photography? So we're looking for number of students, okay? All right, so I don't know what the percentage of photography is, right? That's X right now. But I do know I'm dealing with 100%. And if I have 28% like drawing, 25% like cooking, 15% like ceramics, and 8% like Spanish, all I have to do is add these up and subtract them from 100% to figure out who likes photography. So I have 5 plus 5 is 10 plus 16 because 8 plus 8 is 16. And I get 26. And then I have 2, 4, 6 plus 1 is 7. And I have this, what I know right here is from here to here is 76%. Okay, that's 76%. So that leaves me with this here. Well, what's 100% minus 76%? That's 24%. So 24%, let me get this X off of there for you. This 24% is going to be the remainder. 24% want photography. Now, some of you have your little box here. You go, oh, got it, 24%. Done, and you move on. Careful. They're not asking you what percent. They're asking you how many students. So now I have to figure out what is 24% of the 300 students who are taking this survey. I'm not done yet. So let me take this off of here because I can't fill in my box yet. So 24% of 300 students. Well, what does that mean? That means 300 times 24%, because of means to multiply. So 24% of 300 students chose photography. So we multiply 300 times 0.24. Let me do that in my calculator. And I get 72 students. 72 students. You don't have to write students. You'll just write 72, but I'm writing students so you know. It's not 72%. It's not 76%. It's not even 24% here. It is 300 times this remaining 24%, which gives us 72 students. So be very careful there. So just to recap the steps, I looked at my pie chart. I know I'm dealing with 100, okay? I have 300 total students. I'm trying to figure out how many students chose photography. Well, first I have to figure out the missing percentage. So I add up all the percentages I know. 28 plus 25, drawing is 28, cooking is 25, plus 15 for ceramics, and plus 8% for Spanish. That gives me a total of 76. Well, if this is 76, then this piece right here for photography is 24%. But I'm not looking for percent. I'm looking for how many students. So 24% of 300 students chose photography. So I take 300, multiply it by 0.24, and I get 72 students chose photography. All right, very good. Now, right here is when things get a little bit crazy, I feel like, with students, my math students. When we see a scatter plot graph like this, sometimes we get a little bit freaked out. But I'm going to show you some tricks and tips for scatter plot graphs that will help you. First of all, whenever you see dots like this, we're talking scatter plot, and we're looking for a correlation, okay? Correlation, not causation, correlation, Okay, now that'll make more sense in a minute when I talk about it. So I'm going to go ahead and pull up this blank screen here because I want to show you a couple things about scatter plot graphs. So let's say I have two graphs here and do my best to draw these really, really well. All right, and I've got a bunch of dots that are kind of stuck together in a pattern, and they're moving like this up the graph. Notice that my dots are like condensed. They're going in a pattern. They're moving up, right? They're going this way in a line. I mean, it's not a straight line. It's got a bunch of little dots all over it, but there's definitely a pattern here. This is what we call a strong correlation because the dots are all stuck together like this, okay? Now, a weak correlation is when, you know, it might be going, but it's kind of like, it's a little bit less, you know, defined. This one, all the dots are like clustered in this line, right? This one, you might have a couple dots over here. It's moving that way. You know, you definitely see a pattern, but it's not that tight pattern where you can see a definite correlation. So where this one was strong, this one here is weak. Yes, it's going this way, but it's still weak. Now, both of these are moving in a positive direction because when the graph is going up, we're talking about a positive correlation. If the graph goes down, we're talking about a negative correlation. So a negative correlation is going to look like this. Let me go here. I'm going to do the opposites here. So let's say I have nice tight circles here, and they're moving this way. My dog just came in here. So it's moving this way. Notice that it's moving down this way here, okay? So it's moving down, which means it's a negative slope, all right? Just like your bank account. If this is your bank account, you start up here at $100 and it's going down as the days go by, your account is going negative. Scores, you want your scores to be going like this, right? In the positive direction, not the negative direction. So this is actually a strong negative correlation. We'll go negative here and we'll go positive here. This is a weak positive. This is a strong negative, right? Negative. Now, let's say we have, you know, some dots, they're moving kind of in the negative, but do you see how they're kind of loosey-goosey and they're not super defined? This is still negative, still moving down, but it's weak. So here we have a strong positive. Here we have a weak positive. Here we have a strong negative, and here we have a weak negative. Now that'll help you with 99.999% of any scatter plot graph that you have. Now let's go take a look at this question now that we know. We've got a scatter plot. Look at my dots. Are they moving in a pattern? Yes, they are moving in a pattern, right? They're definitely moving in a pattern. They're moving a certain way. But are they nice and tight? Do they follow like a definitive line? No, they don't. I also noticed that it's going this way, right? It's going in the more positive direction. So we're basically saying that as the hours exercised increase, notice we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, as it goes up, so does weight loss. Weight loss goes up because you're counting how many pounds you've lost. So, oh, I lost 5 pounds. Oh, I lost 10 pounds. Oh, I exercised, you know, 7 hours this week or 10 hours. People who exercise 10 hours a week lost more weight, right? It's correlated with losing more weight. It's not causation. We never say it causes. We just say it's correlated. So we know that it's a positive. So I'm going to eliminate any negatives. And you can see here I have negatives. So I'm going to eliminate B. And do I have any more negatives? Strong positive, strong negative, weak positive. Okay, that's the only one I can do. Now, the other thing I can eliminate is anything strong because this is not a strong correlation. It's a weak correlation because the dots are all over the place, little loosey-goosey there. So this one says strong, so I'm going to take it off. This one says weak. This one has something else, and this one says no correlation. I'm going to take off the no correlation because let me show you what no correlation is. Let me go back to my thing here. Let me add. All right. A no correlation is when you have something like this. It's a hot mess. Everything's all over the place. This is no correlation. Okay, nothing's happening there. We cannot figure out what's going on. We cannot make a correlation. We probably need to redo our study or look for something else. Okay, so that's important there. So that correlation, no correlation, I'm going to take out because there's a slight correlation here. We can see it's moving in that direction. It's not strong, but there's a slight one. And then it says here for D, the more that people exercise, the more weight they will lose. Now this equals causation. We're never talking about causation. So if you see that on the test, eliminate that. We're looking for a weak positive correlation between hours exercised and weight lost. Now, if we were talking about pounds lost or total pounds, your total, not pounds lost, I'm sorry, how much you weigh, there would be a negative correlation because as you exercise more, your weight goes down. So the graph would look like this. Your weight would be here. So let's say you're 300 pounds here, and then 250, and then 200, and then 180, you know, going on down until you get to like 110 here, right? And then this is hours worked out. 1, 2, 3, 4, 5, 6, 7, 7, 8, and on down. And so we could see a negative correlation, right? If we were talking about weight loss versus hours exercise, in that case, it would probably be going down like this. But in this case, we're counting how many pounds lost, not your weight. So in this case, it's a positive correlation because it's going up. Negative correlation doesn't mean bad. It just means as one goes up, the other goes down. So as I exercise more, my weight goes down. Right? In this case, I'm doing pounds lost. So as I exercise, the amount of pounds I lose goes up. I lose 5 pounds. I lose 10 pounds. I lose 20 pounds, right? So that's going to be a positive correlation. You don't have to get too much into that. I'm just trying to show you the real world application. Just know that when the arrow's going up, it's positive. When the arrow's going down, it's negative. When the circles are nice and tight and form a tight, 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 tight line, and it will be obvious, it's going to be a positive, strong positive. And if they're not, and they're a little loosey-goosey like it's going on right here, it's going to be a weak correlation. And if you see them all over the place like this, it's no correlation. But you will never choose D because this is causation, and that's not what we're talking about. We're talking about correlations when we talk about scatter plots, all right? Now, let's take a look at another one. Well, this one is number 8, but I want to skip this one for a second because I want to go to the other scatter plot graph here. Okay. I threw in number 8 as an extra last minute because somebody asked me for it. So let's take a look at this here. Now, this one's a little more complicated because like I say, I always look at my answer choices here and I can see, oh my God, I don't know what that equation is. This is crazy. I don't like this. And I understand because this can be very difficult. But what I see here is slope-intercept form. And that is y equals mx plus b. All right, so I'm going to keep that in mind. I'm thinking about slope. I also can look at this just to recap. Notice how tight the circles are next to one another. Okay, so here we have a strong correlation, right? They're all together and they're forming a line, and that line is going up. That line is going up. So this is a positive slope. So what can I do? Well, one thing you want to pay attention to, and let me just change to my pen because slope is this right here, m. It's what is attached to the x, and it's usually in a fraction form. So in this case, my slope is 2 for A, -2 for B, 1/2 for C, 1/2 for D, and -1/2 for E. Well, right away, I can eliminate 2 answer choices because my slope is going up. It is a positive slope. Make it a little darker here. There we go. So my slope is going up. So let's eliminate anything with a negative. That means B is out because it's -2, which means it's a negative slope. And E is out because -1/2 is a negative slope. So now I narrowed, even if you didn't know anything about this question, you just narrowed it down to only 1, 2, 3 left that you have to choose from. So you just increased your chances right away. Now, I'm going to teach you a trick to figure this out without having to do any kind of crazy calculation. I'm going to do it the old-fashioned way, the way I learned when I was in middle or high school back in the day, okay? We're talking rise over run to figure out the slope, which is y over x, because this is your y-intercept here, and this is your x-intercept here. You go up and down on the y, you go left to right on the x. So if it's rise over run, it's y over x, all right? So your slope is going to read y over x. So let me pull my slopes out here so you can see them right here. So let me choose a different color. I'm going to go with purple. All right, so this slope is 2 over 1 because 2 is 2 over 1. So y is 2 and x is 1. Rise over run, y, x, okay? I eliminated b, so I don't have to worry about that. C is 1 over 2. That means the y is 1 and the x is 2. And d is 1 over 2. Those are my slopes, all right? So let's start with a here because 2 is pretty easy. All of these are pretty easy to calculate. What I want you to do is find a dot that's in like a good place that you can see it. And you can see here, this is right at the cross hairs, right? It's right there on that cross. Let me just show you really quick. Notice that that dot right there, this one, I'm talking about this one right there, is on the little cross where the X and the Y meet. So that really helps a lot. So I'm going to start with that one there. And notice that, be careful here. These are 2s, not 1s. If you forget that, you'll think it's 1 and it's a 2. So when I start, if I start from 0 here, I went up 2, because 0 to 2 is 2, and I went over 1. I went up 2 over 1, up 2 over 1. Do you see how it's kind of following that up 2 over 1? Now, it's not perfect because it's a scatter plot. If this were a perfect line, let's just say this was like a line that went like perfectly straight, which this is not straight because I'm drawing it freehand, then you could have a more definitive slope. We're gonna estimate here, and that's okay because on this test you'll be able to do that with the answer choices. So we're gonna estimate. So right now 2 over 1 looks good to me. All right, I've got, if I start here, I go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. And notice it follows the pattern and brings me here. Now let's just try to eliminate. So I'm going to choose A and move on with my life if it's test day, because I want to get out of this question. Because if this is something that makes you crazy and it's really hard to do, you're going to want to choose your answer and move on and work on the questions that you're really good at and grab those answers there. But for the sake of this presentation, let me go ahead and eliminate C and D. So let me erase my line. Oops, let me erase my line here. Now, if I'm going up 1 over 2, remember, rise over run. So if I start here and I go up 1 over 2, up 1 over 2, up 1 over 2. Notice what's happening with my line here. It's like this. It's going down there when really my line is going up here. All right. So 1/2 is definitely not my slope. Another thing that you can check just to make sure is this number here. This is the y-intercept. Where does it start? Okay. And in this case, if we were to take this and draw a line, we'd really be starting right around here, which is 0.04. If we started at 6, look, 6 is way up here. That's for C. that's going to have the line going up here, not where it is. Okay, so C is out for both reasons. The slope is incorrect and the y-intercept is incorrect. Okay, now let's check this y-intercept here. 1, that's a little bit closer, but if we started at 1 and we went up 1 over 2, up 1 over 2, up 1 over 2, we're still too short. We're going this way. We're too far down on the y-intercept. We're too far down. So the best answer is A. Now, look, again, this is a crazy problem. We know that y equals mx plus b. We want to take a look at the slopes, eliminate the negatives because it's going up. If it were going down, you could eliminate the positives in this situation. And then what you want to do is take an estimated guess of rise over run, which is y over x, and just count. Careful, notice here, as you go up, it's in 2s, not 1s. If you were moving fast and you went, okay, up 1 over 1, up 1 over 1, okay, the slope is 1. Or if you went up 1 over 2, you would be mistaken here and you would be drawing the right line, but you would be using the wrong slope because this is going 2, 4, 6, 8, 10, 12, 14. It's going by 2s. And these are going by 1s. 1, 2, 3, 4. Do you see that? And they even do another trick. Notice that these boxes are smaller than these boxes here. So your brain wants to think, oh, this is going up 1 and these are going over 2, but they're not. The bottom is going over 1 and the y-axis is going up 2. So that can also be a little trick there. So be careful of that, okay? All right, now let's go to this one. This is number 8. Let me just get rid of this 8 and write it in. Okay, this was a fan favorite, and I want to make sure that we do this for you all because this is a proportion, and this is going to be part of data probability and stats because proportions are definitely part of data probability and stats. So, and this can make people crazy. So we have a model of a statue measures 8 inches wide by 6 inches tall. If the scale of the model to the actual statue is inches to feet in a ratio 2 to 5, what is the height of the actual statue? Okay, so there's a lot going on and there's actually some extra information in here that you're going to want to forget about, okay? So we have let's just draw it out. I'm going to do it just with lines here. So we have a model statue. So we've got the height and then the width, right? So the height is, a statue measures 8 inches wide. So we're 8 inches here and 6 inches tall. But the scale to the actual statue to feet to inches is 2 to 5. So it's every 2 inches is 5 feet. That's what they're saying here. Every 2 inches is equal to 5 feet. And then it says, what is the height of the statue? So I don't need to worry about this width. I only have to worry about this inches. Okay, now let's go with this ratio here. This is 2 over 5 or inches over feet. We want to do matchy-matchy. When I talk about proportions, I always talk matchy-matchy. Inches over feet equals inches over feet. In this case, we have 2 inches over 5 feet. Let me move it. Since we don't, well, I'll keep that for the notes, sorry. Let's go 2 inches over 5 feet equals 6 inches over, I'm not sure how many feet. Okay, so it's 2 over 5 equals 6 over x. Make sense? I'm only dealing with the height. So I'm only dealing with this 6 here. Sorry about that. With this 6 here. And my scale is 2 inches equals 5 feet. Inches over feet equals inches over feet. 2 over 5 equals 6 over, I'm not sure because I don't know how many it's going to be and I need to put that as an x so I can cross multiply and solve. When I do, I get 2x equals 6 times 5 is 30. So I have 2x equals 30. Then I'm going to divide by 2 because I want to isolate the x, divide by 2, and I figure that x equals 15. So the actual height in feet, because this is just a scale model, this is just a mini version of the big version of the statue that's out in front of the building or whatever. This is actually 15 feet. All right, let's recap our steps again. This is one that you have to write in, so you couldn't look at your answer choices like I normally like to do. I see here that it's a model, and I have the word scale. So I know that I have something that's outside in the real world, but then I made a model of it that's a little smaller, but I made it to scale, meaning the arms are the right size, the legs are the right size, whatever the statue is, okay? So I have a model of a statue that measures 8 inches wide, which we put here, and 6 inches tall, which we put here. If the scale of the model to the actual statue is 2 inches is really 5 feet, so every 2 inches equals 5 feet outside. So every 2 inches on the little statue equals 5 feet on the big statue outside, okay? That's my ratio. So I have inches over feet, because when you write ratios, like 2:5 is 2/5, always. That's the way you write it. 2:5 is 2/5. So I've got inches over feet equals inches over feet, my matchy-matchy. Okay, matchy-matchy. So I've got 2/5 inches over feet equals 6 inches over, not sure how many feet it is. I need to figure that out. Cross multiply and solve. And when I do, I get x equals 15. It's 15 feet tall, the real statue. Okay. All right. And I believe that brings me to, all right, probability. This one is also a proportion. Let me write down the number, which number that was. Here we go. This is number 12. Sorry, I didn't put that on this is number 12 in your handout. All right, so we have a paper bag contains 6 red squares, some yellow squares, and 8 blue squares. If the probability of selecting a yellow square is 5/12 or 5/12, how many yellow squares are there in the bag? There's 2 ways to solve this problem, okay? I'm going to solve it a certain way. I've got 6 red squares here. And I have 8 blue squares. 1, 2, 3, 4. I'm going to make them circles because squares are too hard. Circles are easier to draw, okay? So I have 6 red and 8 blue, all right? And I have some yellow. I don't know how many yellow, but I know that the probability of choosing a yellow is 5/12. Now, let's take a look. This probability has been reduced because remember, with probability is part over whole, or your pick out of the total, right? If I said how many, if you've got 30 things in a bucket and 10 of them are green, what's the probability of picking a green item? It would be 10 out of 30 because you have 10 chances to pick out of a total of 30. In this case, 5/12 is equaling what my probability of picking a yellow is out of this. But I can tell this is reduced because I have 6 red and 8 blue already without even knowing the yellow. That's 14. Well, 14, at least 14 should be on the bottom because I also have some yellow squares. So I know that this is a reduction. So 5/12 is reduced. Now, how do I find it? How do I find that probability of picking yellow? I'm going to set up a proportion again. So I have part over whole. So I know that I need my yellow pick is going to go at the top. All right. Now on the bottom, I don't know my total. I know I have 6 red and 8 blue. 6 plus 8 is 14, right? But I also have the yellow. I don't know what the yellow is, but I can still solve this equation. So my yellow is my part over my whole, which is 14 plus the yellow, because that's the whole. I need the whole. I need the red, I need the blue, and I need the yellow. So what I can do here is I can cross multiply and solve. In this case, I get 12y, because 12 times y is 12y, equals, now be careful here. This is 5 times the quantity 14 plus y. Now, 5 times 14 is 70. Check my math just in case, but it should be right. 5 times 14 is 70. Don't forget your y here. Don't say 70 plus y. It's 70 plus 5y. Careful. When you do, you solve by algebra. Get rid of this y here. Get rid of this y here. And we get 7y equals 70. Divide by 7. Divide by 7. And I get y equals 10. So there are 10 yellow in the bag. Now we can check it here. Let's go over to this side, over to the left. Let's check it. So we've got 6 red, 8 blue, and 10 yellow. So that means I have 24 total in the bag. And if I have 10 yellow, my probability of picking a yellow is 10 out of 24, which if I reduce it as much as it'll go, that means if I divide this by 2 and I divide this by 2, I get 5 over 12. So that's a way to check. Now notice that I just checked it. Instead of doing this, like let's say you're not comfortable with this. I'm very comfortable with proportion. I use it all the time. I'm also teaching math constantly. So it's all good. You know, I can do that. But we want to make sure that we are, you know, doing the things that make us feel most comfortable here. So we could also plug this in. I could take the 7 and go 6 plus 7 is 13, right? Yes, 13 plus 8 is 21. Well, that would be 21 total. And our yellow would be 7. 7 over 21 does not equal 5 over 12. We need something that goes into, that 12 can go into. We need that bottom number to be 24. So you could do the same thing with 8. You could say, okay, let's say it's 8. 8 plus 8 is 16, plus 6 is 22, sorry. And these are going to go in order. This is going to be 21. This is going to be 22. This is going to be 23, right? Because the answer choices go in order. This is going to be 24. So if we've got 22 as the whole, and we have 8 as the part, because 8 is what we're doing here, that does not reduce to 5/12. So you could go down the line and do that as well. Both of those methods work, okay? All right, let's take it to algebra and geometry now. Now, algebra and geometry is going to be 32%, and that's going to be 18 questions, okay? Now, I like this. I'm going to need to kind of go a little darker because we're working on a light screen here. So I'm going to look at my answer choices here first before I do anything. This is number 13 in your handout. Notice that it's choose all that apply. I hate these because these are much harder than just your pick one, and they're worth more points. This one, if there are 3 correct answers, it's worth 3 points. If it's 2 correct answers, it's worth 2 points. So be careful there. So it says, choose all of the following that are equivalent to the expression 4a squared. So I need to figure out which one of these equals 4a squared. Now I like this one because it talks about exponents and multiplying and dividing. And I think you need to know this for sure for the test. Now, let's take a look at number 1, 2a plus 2a. Be careful. 2a plus 2a is 4a. Not 4a squared, all right? So we want to make sure that it is not you're not talking about 4a squared, it's just 4a. I'm taking 2a and I'm adding 2a and I'm getting 4a, that's it, 4a, not 4a squared, okay? Now, if this was, let me erase this. If this was 2a times 2a, then that would be 2 times 2 is 4. A times a is a squared. In that case, it would be 4a squared, but it's not. It's just 4a because this is not multiplication, it's addition. So number 1 is not the answer. So I'm not going to check it. All right. So 2a plus 2a, let me keep these in here so that when I send this to you, you'll get it 4a. All right. Not 4a squared. Now let's take a look at the second box here. 4a times a. Well, 4a times a is 4a squared because, let me make that better, sorry. A times a is a squared, just like 3 times 3 is 3 squared, and 4 times 4 is 4 squared. We're just talking about a variable and not an integer here. So a times a is a squared, and in this case, you just tack on that 4 and you get 4a squared. So I'm going to check the second box there, all right? Now let's take a look at 6a to the third minus 2a. Be careful. You might say, oh, 6a to the third minus 2a. Well, 6 minus 2 is 4, and 3 minus 1, because this is really a to the 1, is a squared. Okay, so that's 4a squared. No, it is not. When we are talking about adding and subtracting, you cannot combine unlike terms. You cannot. You can only do like terms. And in this case, this is a to the third and this is a. You cannot combine them. This expression is reduced as far as it will go. You have to just keep it here, okay? So make sure that you know that this is as far as it goes. You can't take it any further. So I'm not going to choose box 3, all right? Let me just take that there. This is 6a to the 3 minus 2a. Can't do anything there. Now let's take a look at this one here, the fourth box. I have 8a to the 4 over 2a squared. Now this little bar here is division. I'm basically dividing 8a to the 4th and 2a squared. Now in this case, we are going to divide 2 into 8, and I get 4, and now I have a to the 4th divided by a to the 2nd. Now, even if it weren't like terms, I could still do it because it's division. Adding and subtraction, you have to have the same base. But in multiplication and division, you don't. So in this case, I have a to the 4th divided by a squared. And what you do is when you divide a to the 4 divided by a to the 2nd, you essentially subtract the exponents. And in this case, it would be 4a squared because 4 minus 2 is 2. So in this case, the fourth box, a to the 4 divided by 2a squared, 8a to the 4 divided by 2a squared is going to be 4a squared. So yes, that one works. And now let's look at the last one here, 3a squared plus a squared. Now in this case, I have addition, but I have the same bases here. So can I combine them? Yes, I can. In this one here, I don't have the same bases. I have a to the 3rd and then just an a. Can't combine. But this one I have a squared and a squared. And here's what happens. All you're doing is you're taking 3a squareds and you're adding another a squares, which gives you 4a squared. So 3a squared plus a squared equals 4a squared. What you're essentially saying here is a squared, a squared, a squared, that's 3a squares, plus another one, a squared. Well, how many a squareds do I have? 1, 2, 3, 4 equals 4a squared. All right, so you would check the last box as well. So those are your exponents. I covered several of the exponent rules. Remember, if you're dividing exponents, you're actually subtracting them. If you were to multiply them, let's say this was a to the 4th times a to the 5th, they're different bases, right? If this was a to the 4th minus a to the 5th or a to the 4th plus a to the 5th, I couldn't do anything else. It would have to stay. But this is a to the 4th times a to the 5th. Well, what I essentially do there is I add, this is a to the 9th. All right. So hopefully that helps you out there with exponents. That will be a help for the exam. All right, and let's go to the number 15. Now, number 15, I'm going to show you an awesome hack on how to do these inequalities. And it's going to help you a lot on the exam. So we've got this problem here. It's got a bunch of stuff, but remember what I'm going to do is I'm going to go to the answer choices first, and I'm going to immediately see these inequality signs here, and I'm going to get very excited. Most of you get very upset when you see this if you're not a math person, but this makes me happy because I know I'm going to be able to eliminate a bunch of answer choices, okay? So I want you to pay attention to those inequalities, and this is a trick on almost every single standardized assessment you will take with this kind of problem. Notice they're not asking for an answer. They're asking for the right equation, all right? And this might make you crazy if you're not an algebra person, but you're not even going to have to do algebra, so don't worry about it. So I'm going to go a little lighter here. Let's go to peach. Okay, so we have, if shirts cost $30 and pants cost $48 and John has $300 to spend, which answer choice represents how many shirts and how many pants he can buy? Let S represent shirts and P represent pants. Makes sense, okay? So we definitely are going to have S is going to be 30 attached to the 30 and P is going to be attached to the 48. But what I care about initially is this, 300. I have $300 to spend. That means I can spend 1 cent all the way up to $300. So I can spend $300 and I can spend less than $300. Can I spend more than $300? Can I spend $301? Can I spend $302 or $450 or $500? No, I cannot. I only have $300 in my pocket, or John in this case only has $300 in his pocket. This is easy. So now I can eliminate any answer choices that have greater than in it because I cannot spend anything greater than. These shorts and pants cannot add up to something greater than 300. So right away, I can eliminate C because of this greater than sign, and I can eliminate D because of this greater than sign. They're out. And now all I have left is A, B, and E. Now, A is just a less than sign, and E is just a less than sign. That means that I can spend 0.1 or 1 cent all the way to $299. Is that true? Can I only go to 299 or can I go to 300? I can go to 300. So less than by itself is not proper because I can spend 300 or less than 300. So it should be less than or equal to. And in this case, this is just less than. Pull it out. And this one is just less than. Forget about it. B is the right answer. Because of this, let me get a little green here. Because of this inequality sign, it's telling me I can spend 1 cent all the way to 300, but I cannot pass 300. And I did not have to do anything. Please pay attention to this. Right away, if it's spending money or anything, you have to sell this many houses or anything like that, there's a definitive number, it's going to be less than or equal to. All right. It could also be greater than or equal to. Let's say you have to spend at least $300. Well, if you have to spend at least $300, you have to spend $300 or more. That would be greater than or equal to. In this case, you have to spend 300, equal 300, and more. So that's where the greater than or equal to would come in. But in this case, we're looking at less than or equal to, and this would be just less than, this would be less than or equal to. This is the one we want here. All right. Hopefully that helps you when you get to those. Another bit of algebra for you here. This tends to make people upset too. We're looking at 2a plus 5b equals 8. What is a in terms of b? All they're asking you to do here is put what is A in terms of B. We're putting A on one side of the equal sign and B on another side of the equal sign. That's all they're saying there. They're not saying A equals B. They're just saying A is going to be here and B is going to be on the other side. That's what we want. Currently, they're both on the same side of the equal sign, so I cannot figure out what A is in terms of B. So what I want to do is I want to isolate the A and get the B over to the other side. I also want to take a look at my answer choices. Notice that they're all in A equals. That means that my equation has to isolate the A. The A has to be on its own, all right? Now to do that, I got to do some algebra. So let's go 2A plus 5B equals 8. I always like to rewrite it because that's just how I am. So I want to get this alone here. So what do I need to do? I need to subtract 5B. That will eliminate it from this side, but whatever I do on one side, I have to do on the other. So this is 2A equals 8 minus 5B. Now I'm not done yet. I got to get this A alone because all of my answer choices here are in A equals. So I'm going to, because the 2 is multiplied by A, or 2 times A here, I'm going to divide it to cancel it. And I'm going to divide it here. Now remember, everything you do on one side, you have to do the same thing on the other. So in this case, I get A equals 8 divided by 2 is 4 minus 5 over 2B. And that is answer A. So it's as simple as that. It's just algebra, moving the variables around. So you get A by itself over by the equal sign. That's why your answer choices are so important here. Because looking at the answer choice right away tells me I got to isolate that A. I got to move some stuff around and make sure that I have A by itself, A equals. Okay? And then the last problem here, this is going to be a geometry problem that looks way scarier than it is. All right. So we have if lines A and B are parallel, that's important to know. What is the value of X in the figure below? All right. What is the value of X in the figure below? So we have X plus 10 is right here. So we're looking for this guy right there. All right. X plus 10. Now, here's what a lot of people might do. They might say, okay, well, a triangle is 180 degrees. So 90 plus 40 is 130. 180 minus 130 is going to give me 50. That's 50 degrees. If this is 90, then this is going to be 40 here. And you're trying to figure out all these different angles. Here's an easier way. They're doing this to you, so you know this. A and B are parallel. That means that whatever line intersects them, opposite interior angles are always equal. So that means if this is 40, then this is 40. And notice, this is 90 degrees here. So is this. So this is 50 here, because 50 plus 40 is 90, but I don't care about that right now. Just showing you a little example. So if this here is 40, then this here is 40. And another thing that's equal are opposite angles, meaning X plus 10 is equal to 40. So all I would need to do is go X plus 10 equals 40, solve for X. X equals 30. It's as simple as that. Let's try it again one more time. Just so you know, because you will see this and people tend to go, oh my God, I don't know this. You do know it. You do know it. Opposite interior angles. If the lines are parallel and it goes like this, just look, opposite interior angles. Look at this here. This one here and this one here are equal. This here and this here are equal. There's all kinds of equals going on here because they're parallel lines. But I'm trying to figure out what this is equal to. Well, the best way to do that is say opposite interior angles here, 40 degrees. That's there. And also opposite angles are equal. So you can see that X plus 10 equals 40. Solve for X. X equals 30. And you had to write that in, I believe. I don't think I had answer choices. No, I didn't. That was a put it in the box, 30 degrees. Okay. So that'll help you there.